So in this part of the lecture, we will talk about applying Newton's second law. Well, what is Newton's second law? Newton's second law says F equals ma. Sum of the forces is equals to ma. So some hints for problem solving. As always, read the problem very carefully, draw a picture of a system, identify the object of primary interest, and indicate the forces with arrows. Label each force quantity in the picture in such a way that you will remember or recognize what each physical label stands for. For example, T stands for tension. Draw a free body diagram of the object of interest based on the labels of the picture. Choose a convenient coordinate system for each object under consideration. Apply Newton's second law. Take the x and the y components of the Newton's second law independently. Solve the desired equation and substitute numbers. Remember, F net in the x direction is equals to max, and F net in the y direction is equals to may. So example 1. Find the tension in the cord connecting the two blocks that are shown below. Force of 10 newtons is applied to the right on block 1, and this accelerates the block. Assume a frictionless surface. The masses are m equals 3 and m equals 1 kilogram. Another assumption that you should always make is that the rope stays taut in such a way so that both blocks have the same acceleration. So we will only consider the cases where both have the same tensions as well as the same accelerations. So our question says we have two blocks, M1 and M2, and there is a force that's being applied to it, and then this is a force. Now in this case, always remember that you have to take these both masses individually. You can't take them as one mass, okay? So let's say this is my mass 1 and this is my mass 2. Now I have to write equations of motions for both mass 1 and mass 2. So let's start off by writing for equations of motions for M1, and then I'll write the equations of motions for M2. Okay, so this is M1. What are all the forces that are acting on it? Well, there are going to be, this is a guarantee. There will always be a force of gravity that's acting downwards on it, and there will always be a normal force that is acting from the surface in contact. Okay, so let's say, suppose this is a surface in contact, right? Okay, and M2, for M2, I know for certainty that for M2, it will have M1, M2G acting downwards and a normal force acting upwards. I'm just going to call it N2. Actually, it might be easier if I just call this one M2 and this one as M1, just so that they follow into the same category. Okay, now, what do we know? I know that this accelerates the blocks. Okay, so now we have to be very careful. So for M2, let me write all the force equations that are on M2. Sigma Fx, 1. Sigma Fy, 1. Okay? Now how many forces along the x direction? Well, assuming that this is a frictionless surface, the only force that's acting on the block apparent is the force that is being applied. Okay? However, this is not the only force that's acting on block M1. It also has a tensional force that is arising because of the presence of M2. Tensions. And these both are going to be equal and opposite. So that means I have to include that when I'm talking about my mass 1. So I'm going to call this T1 and this T2. Okay? So the force acting on this direction is that one, and then there is a tensional force acting on the opposite direction because of the presence of M2. Okay? For my y direction, I have a normal force that's acting up, and I have a gravitational pull that's acting downwards. So these are all the forces in M1. Now let's talk about M2. So what are all the forces that are acting on M2? Well, sigma Fx, 2, and sigma Fy, 2 is what I have. So looking at this, I can say it's N2 minus M2G. And for F2, there is only one force that's acting on it, and that's T2, and that is in the plus direction. Okay. So now comes Newton's laws. Newton's law says that the sum of the forces is equals to ma, or it is equals to 0, depending on the situation. So in this case, these both blocks start to accelerate. This means Fy is 0 because there's no direction, no acceleration in the y direction. Fy is 0. However, this is now going to be m1a, and this is now going to be m2a. Actually, technically it should be m1a and m2a, so I'm just going to write m1 and m2. But I know that both these accelerations will be the same, so I can get rid of those subscripts. Same thing happens for T1 and T2. Because they both have the same tension, they are the same in magnitude, I can get rid of this subscript, and I can get rid of this subscript. So, if I was to take this as equation 1, this as equation 2, this as an equation 3, and this as an equation 4, I can rewrite all of these expressions as the following. So from 1, I have m2a equals tension. From equation 2, I have n2 equals m2g. Okay. From equation 3, I can rewrite m1a equals f minus t. And from equation 4, I can rewrite 0, or in fact, n1 equals m1g. Now I have all of the stuff that I need in order to solve for this. What was my initial problem that I needed? I needed to find the tension in the course. Well, I can find the tensions from the first two expressions. So I'm just going to rewrite 1 and 3. So equation 1 says m2a equals tension. And equation 3 says m1a equals force minus the tension. Okay? I have two equations and two unknowns. I can solve for these and come up with an answer. So using our same trick that we did last time, we're going to just divide these two together. Okay? This means a's will go away, and I will have m2 over m1 equals t over f minus t. Okay? And I know m2 because it's given to me, which is 1 kilogram. And I know m1 because it's given to me, that's 3 kilograms. Tension is what I'm looking for. And applied force is also given 10 newtons minus t. Now all I need to do is do some algebra, move things around, and come up with a value of tension. So go ahead, come up with an answer. I come up with 2.5 newtons as my answer. But go ahead, do your own calculations, make sure that it actually works. Okay? This is a very typical question in physics that we are very used to seeing. So if you can follow these steps and do the same things over and over again, it will be very useful. Now let's change this question slightly. It's the same exact problem, but now let's introduce frictional forces between the object and the floor. How does this equation change? Well, if the acceleration is that way, then that means there is going to be an frictional force, this way. So let's call it F1. I usually represent frictional forces with little letters F, just for myself. You can call them whatever you feel comfortable with. And this is going to have a frictional force 2 in it. Now, note what's going to happen. My expressions, first of all, will remain exactly the same, except for one small difference. Because of this additional frictional force, this will be included into your equation number 1. So for example, this will have an additional term, friction 2, and this expression right here will have an additional term, minus frictional force 1. What that will do is actually change how I solve these problems slightly. So my equation 1 will now have a minus F2 in it, and this one will have a minus F1 with it. Everything remains exactly the same, but you have one more term. The other thing you have to recognize is the fact that your frictional force, if you remember, was given by mu n. So frictional force 2 will become mu 2 n2, and frictional force 1 will become equals to mu 1 n1, where n1 can be found from this expression and n2 can be found from this expression. So basically the idea in physics is that you don't really change the question, you just change parts of the question, which changes the whole solution slightly as you go forward. But it's basically the same question. The main idea is, can you write these force equations, and can those force equations help you go forward and solve all the problems that you may have?